dear students, last class we completed thermodynamics. Today we are going to do some questions from some MCQ question from thermodynamics. So I'll start with first question. So first question, a gas is allowed to expand. A gas is allowed to expand in a well insulated container against a constant external pressure of 2.5 atmosphere from an initial volume of 2.50 liters to a final volume of 4.50 liters. The change in internal energy delta U of the gas in joules is. Okay, so here a gas expands from V1 volume to V2 volume. A gas expands from V1 volume to V2 volume. V1 volume is, it is given there, it is 2.50 liters, and V2 volume is given as, V2 volume is 4.50 liters, right? Now, external pressure is given, the piston is moving against an external pressure of, here external pressure. Piston is, or the gas is expanding from V1 to V2 against an external pressure of, external pressure is giving, it is 2.5 atmosphere, right? So external pressure is given, V1, V2 values are given. Now a gas is allowed to expand in an well insulated cylinder. The cylinder is insulated. What does mean by insulated cylinder? Insulated cylinder means no heat absorbs or leave the system. No heat enters or leave the system. No heat enters or leave the system. Insulated system means no heat enters or leave the system, that is Q is equal to 0. No heat enters or leave the system since the system is insulated. I think it's clear. So Q is equal to 0. Now we have to calculate the change in internal energy delta U. We have to calculate delta U in joules. So we have to calculate delta U in joules. Now what is the relationship between delta U, Q? Okay, what is the relation between delta U and Q? You know that delta U and Q are related by first law of thermodynamics. First law of thermodynamics, that is delta U is equal to Q plus W. Delta U is equal to Q plus W. Now here Q value is known, that is 0. We know the value of Q. Now we have to find the value of W, work. Now there are two types of work, which are the irreversible work. The next is isothermal reversible work. Irreversible work and isothermal reversible work. Equation to calculate irreversible work is minus P external into V2 minus V1. Minus P external into delta V. Now equation to calculate isothermal reversible work, W is equal to minus 2.303 nRT log V2 by V1. Okay, so there are two equations to calculate work. One is irreversible work, W is equal to minus P external into delta V, or V2 minus delta V. Delta V means V2 minus V1. Next one is isothermal reversible work. Equation is now W is equal to minus 2.303 nRT log V2 by V1. Now if you read the question carefully, okay, here we have to calculate irreversible work, because you cannot see isothermal reversible in the question. If you check the question carefully, you cannot find isothermal reversible work. A gas is allowed to expand in a well insulated container against a constant external pressure of 2.5 atmosphere from an initial volume to final volume, the change in internal energy. In the question they are not given isothermal reversible. Now if the question contain isothermal and reversible, if those 2 points are given, then you have to calculate, then the work is isothermal reversible work. Since these two words, isothermal and reversible, these two terms are not given in the question, that means the work is irreversible. So to find whether a whether a work is reversible or not, check whether the question contains isothermal reversible. If these two terms are given, isothermal and reversible, if these two terms are given in the question, then that work is always isothermal reversible work. If these two terms are not given, then that work is irreversible work. I think it's clear. So here we have to choose this equation. This is the right equation. This is not the right equation. So here W is equal to, we have to choose this one. So W is equal to minus P external into V2 minus V1. So W is equal to minus P external, that is 2.5 into V2 4.50 minus V1 2.50, that is minus 2.5 into 4.50 minus 2.50, that you will get 2, right? So 2.52 into 2, that is equal to minus 5 liter atmosphere, because here pressure is expressed in atmosphere and volume is expressed in liter. So work is liter atmosphere. So work is liter atmosphere, right? So work is liter atmosphere. I think it's clear. Minus 5 liter atmosphere. I think it's clear. Now we have to calculate delta U. In this question we have to find delta U, right? So we got W value. Now according to first law, delta U is equal to Q plus W. Here Q value is already know it's 0 because it is insulated. Q value is equal to 0, which we have already discussed. Here heat is not entering or leave the system. This is an insulated system. So Q value will be equal to 0, right? So delta U is equal to 0 plus W. That is delta U is equal to, what is W? Minus 5. Minus 5 liter atmosphere. So we got delta U as minus 5 liter atmosphere. Now if you check the question, if you check the options, answers, you cannot find minus 5 liter atmosphere because here the delta U is expressed in joules. Here in the option delta U is expressed in joules, but here we find delta U in liter atmosphere. Now you have to convert liter atmosphere to joule. How to convert liter atmosphere to joule? Actually, you can convert liter atmosphere to joules like this. Actually, 1 liter atmosphere is equal to 101.3 joules. 1 liter atmosphere is nearly equal to 101.3 joules. 101.3 joules. So 1 liter atmosphere is equal to 1.13 joules. So substituting here, 1 liter is 1.013 joules. So 5 liter atmosphere is equal to 5 into 1.1.3 joules, which is equal to delta U is equal to minus 5 3s are 15, right? 5 6 0 5 506.5 joules. 1 liter atmosphere is, you have to remember this equation. Or you have to remember that value. 1 liter atmosphere is nearly equal to 101.3 joules. So 5 liter atmosphere is 5 into 101.3 joules, that is why 506.5 joules. So you'll get delta U is equal to minus 506.5 joules. Now check whether this option is given there. Okay. Now, yeah, this answer is given there. Option C, option 3. Option 3 is the right answer. Option 3, minus 505 joules. Okay. We are getting minus 506.5 joules, but answer close to that value is option 3, minus 505 joules. I think it's clear. This is the answer for the first question. So first question, answer is option 3. Option 3. I think it's clear. Moving on to next question. Now, before discussing question number 2, I need to add one more point. We know that 1 liter atmosphere is nearly equal to 101.3 joules. In a similar way, 1 liter bar, instead of atmosphere, if pressure is expressed in bar, 1 liter bar is nearly equal to 100 joules. So please remember these two values. 1 liter atmosphere is 101.3 joules. Instead of atmosphere, if pressure is expressed in bar, then 1 liter bar is nearly equal to 100 joules. So please remember these two values. Okay. Moving on to question number 2. So moving on to next question, question number 2. Next question number 2. Now, for a given reaction, delta H is equal to 35.5 kilojoules per mole, delta S is equal to 83.6 joules Kelvin inverse mole inverse. The reaction is spontaneous at what temperature? So we have to find the temperature at which reaction is spontaneous, right? So here delta H value is given. Delta H value is 35.5 kilojoules per mole, and delta S value is given. Delta S value is 83.6 joules Kelvin inverse mole inverse. Now we have to find the temperature at which reaction is spontaneous. Now according to Gibbs equation, delta G is equal to delta H minus T delta S. And for a spontaneous process, delta G value should be negative, right? You know that. So according to Gibbs equation, delta G is equal to delta H minus T delta S, and for a reaction to be spontaneous, delta G value should be negative. Delta G value should be negative. It should be negative. I think it's clear till here. Now, here delta H is positive. So delta G is equal to delta H minus T delta S. Here delta H value is positive, 35.5. To make delta G negative, since this is positive, to make delta G negative, this value should be, here delta H is positive. So to make delta G negative, thereby spontaneous, this value should be greater, because then only when we subtract T delta S from 35.5, you will get a negative value. I think it's clear. This is 35.5 in, okay, 35.5, okay, 35.5. So when we subtract T delta S from this value, okay, if this value is greater, then you will get a negative sign. For example, if delta H, let it be delta H be 2 and T delta S be minus 3, you will get minus 1. Instead of that, if T delta is 1, you will get positive value, right? Same way, here in the question they have given that the reaction is spontaneous at what temperature? So reaction is spontaneous, that means delta G is negative. So if to make delta G negative, T delta S value, they are negative, T delta S value should be greater than delta H. So to make reaction RTN spontaneous, delta H value should be less than T delta S. Delta H value should be less than T delta S. I think it's clear. So T is equal to delta H by delta S, or T should be greater than delta H by delta S. I'm taking delta S to this side. Now here delta S is given in joules and delta H is given in kilojoules. So first you have to convert delta H to joules. 35.5 kilojoules per mole. When you convert this into joules, you will get 35.5 into 10 raised to 3 joules per mole. Kilojoules is converted to joules because delta S is expressed in joules. So delta H is 35.5 into 10 raised to 3 divided by delta S is 83.6. It should be less than temperature. Now when you divide this value, you will get a value, you will get nearly, please divide, so you will get nearly 425 Kelvin. So temperature should be above 425 Kelvin. Temperature should be above 425 Kelvin. Okay, temperature should be above 425 Kelvin. Then only the reaction should be spontaneous. If the temperature is 425 or above 425, the reaction will be always spontaneous. I think it's clear. I will explain once more. In this question, delta H value is given, and they have given that the reaction is spontaneous. For spontaneous reaction, delta G value is negative. You know that, right? Delta G value is negative. You know that. I think it's clear till here. Now according to Gibbs equation, delta G is equal to delta H minus T delta S. Now here delta S is already positive. So to make delta G negative, this value should be higher. this value should be higher because delta H is already positive. They have given that it is positive 35.5. So to make delta G negative, this value should be higher. That is delta G is equal to delta H minus T delta S. To make reaction spontaneous, that is delta G negative. To make delta G negative or spontaneous, delta H should be less than T delta S. Right. So T will be equal to delta H by delta S, that is 35.5 into, express this or take delta H in joules. Here it is 35.5 kilojoules, convert it into joules. You will get 35.5 into 10 raised to 3 divided by delta S, 83.6. You will get 425 Kelvin. So that means if temperature of the reaction is equal or greater than 425 Kelvin, then the reaction will be spontaneous. I think it's clear. Moving on to next question, question number 3. Moving on to third question. For a sample of perfect gas, when its pressure changed isothermally from Pi to Pf, the entropy change is given by. So here we have to calculate entropy change, delta S. We have to calculate delta S, and we know the equation to calculate delta S. What is delta S? What is the equation to calculate delta S? Q by T. Delta S is equal to Q by T. Delta S, change in entropy, is equal to Q by T, or you can write Q reversible by T. Delta is equal to Q reversible by T. This is the equation to calculate entropy change. Delta S is equal to Q reversible by T. Right. Now, we don't know the value of Q, but we can calculate value of Q using first law of thermodynamics. According to first law of thermodynamics, according to first law of thermodynamics, delta U is equal to Q plus W, right? But here they have given isothermally, they have given a condition isothermally. The reaction is the reaction is isothermal. Isothermally means the reaction is isothermal. So for isothermal process, they have given that the reaction pressure is changed isothermally. That means the reaction is isothermal. For isothermal process, we know that delta T is equal to 0. Change in temperature is equal to 0. We have already discussed when we discussed the chapter. For isothermal process, delta T is equal to 0. Now, I am adding one more thing here. For isothermal process, internal energy change will be also equal to 0. So, in isothermal process, two important functions, delta T and delta U, will be equal to 0. Okay. We have already discussed for isothermal process, delta T is equal to 0 when we discuss the chapter. And I am adding one more point. For isothermal process, not only delta T but also delta U will be equal to 0. Both the terms will be equal to 0, delta T and delta U. So substituting that value here delta U will be equal to 0. So U0 is equal to Q plus W. So Q is equal to minus W, right? Now if you find the value of W, you will get value of Q. Now here, which equation we have to use? Which equation to calculate W? Work. Here the work is isothermal reversible work. Here the work is isothermal reversible work. How do we know this is isothermal reversible? Because they have given the reaction as isothermal. And also delta S is calculated using the equation Q reversible by T. That means heat absorbed in a reversible process. So isothermal and reversible. Delta S is calculated using this equation Q reversible by T. That means the reaction is reversible and also constant temperature. So this is isothermal reversible work. That is W is equal to minus 2.303 nRT log V2 by V1. V2 by V1. This is the equation to calculate isothermal reversible work. W is equal to minus 2.303 nRT log V2 by V1. But unfortunately, V2 and V1 are not given in this equation. But we know that according to Boyle's law, you know Boyle's law, right? Pressure is inversely proportional to volume. You know Boyle's law, pressure is inversely proportional to volume at constant temperature. According to Boyle's law, pressure and volumes are inversely proportional under constant temperature. So here temperature is constant, so pressure will be inversely proportional to volume. So we can write W is equal to minus 2.303 nRT, right? W is equal to minus 2.303 nRT log. Since V2 is inversely proportional to P2, so instead of V2 here we can write, right, V2 inversely proportional to P2 and V1 inversely proportional to P1. So instead of V2 we can write 1 by P2. Right, instead of V1 we can write 1 by P1. 1 by P1. I think it's clear. So instead of V2 I am writing here. I think it's better to write here. So according to Boyle's law, we know that W is equal to minus 2.303 nRT log V2 by V1. According to Boyle's law, pressure and volume are inversely proportional at constant temperature. So P2 inversely proportional to V2 and P1 inversely proportional to V1. So instead of, or we can write V2 inversely proportional to P2, V1 inversely proportional to P1. So instead of V2 I am writing W is equal to minus 2.303 nRT log V2. I can write 1 by P2 divide by, instead of V1 I can write 1 by P1. So 1 by P2 by 1 by P1, that is A by B by C by D means A by B into D by C. In a similar way, 1 by P2 by 1 by P1 is equal to 1 by P2 into P1 by 1, right? So you will get W is equal to minus 2.303 nRT log P1 by P2. Okay. Now here initial pressure is given as P1 means initial pressure. Here initial pressure is given as Pi and final pressure is P2. Final pressure is given as Pf. So W is equal to minus 2.303 nRT log Pi by Pf. Now we have to calculate Q. What is Q? Minus of W. That is minus of W. That is minus of minus 2.303 nRT log Pi by Pf, that is equal to minus minus plus 2.303 nRT log Pi by Pf. We got Q. Now from this we can calculate delta S. What is the equation to calculate delta S? Delta S is calculated by Q reversible by T. Delta S is equal to Q reversible by T. Now we got the value of Q. What is Q? 2.303 nRT log P1 by P2. 2.303 nRT log P1 or Pi. Initial pressure by final pressure divided by T. Cancelling these two T, you will get delta S is equal to 2.303 ENR log Pi by Pf. So this is the answer. Check whether this answer is given there. Check whether this answer is given there. So, okay. Now, it is not given there, right? Now, we know that what is 2 point... Can I rub this part? So, we know that what is 2.303 log? 2.303 log is ln. So instead of 2.303 log, we can substitute ln. That is delta S is equal to nr ln Pi by Pf. 2.303 log. 2.303 log is ln. So instead of these two, we can write ln nr ln pi by pf. This is the equation. This is the delta S value. This is the delta S value. Answer option 2, nr ln pi by pf. Answer option 2. Answer option 2. Option 2. I think it's clear. I'll discuss once more. Please listen carefully. Delta S is calculated by Q reversible by T, but we don't know the value of Q reversible. So according to first law, delta U is equal to Q plus W. But since the process is isothermal, for isothermal process, two values will be equal to 0. Delta T and delta U. Delta T and delta U will be equal to 0 for isothermal. So this will become 0. So Q, taking this W this side, Q will be equal to minus W. Now, so we have to find Q. So to know Q, we have to find W. Now, this is reversible. Delta is calculated by Q reversible. That means the process is reversible. And temperature is isothermal, okay, constant temperature. The process takes place at constant temperature. That means reaction is reversible. According to this equation, reaction is reversible and it's isothermal. So you can calculate W by using this equation. W is equal to minus 2.303 nRT log V2 by V1. Okay, but according to Boyle's law, pressure and volume are inversely proportional. So instead of V2 by V1, we can write P1 by P2, right? V2 inversely proportional to P2. So instead of V2, we can write 1 by P2, and V1 inversely proportional to P1. So instead of V1, we can write 1 by P1, that is P1 by P2. Okay. Now here, initial pressure is given as Pi, final pressure is Pf. So W, we got W is equal to minus 2.303 nRT log Pi by Pf. Now what is Q? Q is equal to minus W. So minus of this value, you will get Q is equal to this much. Okay. Now substituting this in delta S equation by T, you will get 2.303 nR log Pi by Pf. Now 2.303 log is ln. So ln nR ln Pi by Pf. Answer option 2. I think it's clear. Moving on to next question. So before discussing fourth question, you have to keep this in mind. Isothermal reversible work can be calculated by using these two equations. If volume is given, V1 and V2 is given, then isothermal reversible work can be calculated using this first equation. W is equal to minus 2.303 nRT log V2 by V1. Now, instead of volume, pressure is given, then isothermal reversible work can be calculated using this equation. W is equal to minus 2.303 nRT instead of V2 P1. Instead of V1, it is P2 because volume and pressure are inversely proportional. So these equations are used to calculate isothermal reversible work. Isothermal reversible work can be calculated by using these two equations. If volume is given, you can use this one. Pressure is given, you can use this one. So in third question, pressure is given, so you can directly use this equation. Okay, directly use this equation. I think it's clear. Now for irreversible work, there is only one equation, that is W is equal to minus P external into delta V. I think it's clear. Moving on to next question, question number 4. Moving on to fourth question. So fourth question, the correct thermodynamic condition for the spontaneous reaction at all temperature. The correct thermodynamic condition for spontaneous reaction at all temperature. We know that for spontaneous reaction, delta G values will be equal to negative. Right? For spontaneous process, delta G value is negative. Now, according to Gibbs equation, delta G is equal to delta H minus T delta S. Right? Now, from these options, we have to find in which condition, okay, which condition the thermodynamic process is spontaneous. I'll start with the option A. Option A, delta H less than 0, delta S less than 0. Delta H less than 0 means negative and delta S less than 0 means negative. So you'll get delta H or delta G is equal to delta H is negative. Less than 0 means negative. Delta is also less than 0. That means negative. So delta H will be negative delta H minus T into, and delta S is minus plus. That is delta H minus minus plus T delta S. And this reaction will be spontaneous only at low temperature, because if this term decreases, delta H will be greater than T delta S, delta H term will be less than T delta S, right? If this term decreases, that is T delta S decreases, delta H will be greater than T delta S, then delta H is negative, so delta G will be equal to negative. That means this process will take place, this process will be spontaneous only under low temperature. I think you remember this topic. We have discussed this topic when we discussed about 4 cases. I think you remember when we discussed the topic, we discussed nearly 4 cases. Entropy increases, entropy decreases, enthalpy increases, and the enthalpy decreases. Okay, so from that we can come to the conclusion that this process will be spontaneous only at low temperature. But in question they have given that the correct thermodynamic condition for the spontaneous reaction at all temperature. Here the reaction is spontaneous only under low temperature. Then only, because under low temperature, when low temperature becomes low, this term will decrease. So delta H will have negative value. So delta G will be negative. So this is not the right option. Moving on to second question. Second option, B. Sorry, that will be 1, 2. Delta S less than 0 and delta is equal to 0. Delta H less than 0 means it is negative. Delta S 0. Right. So equation will become delta G is equal to delta H minus T delta S, gives equation. So delta G is equal to, here delta H is minus and T delta is equal to T into 0. So this term will be equal to 0. So delta H minus 0, that is minus delta H. So delta H will be negative. So delta G will be negative, spontaneous. So answer option 2. Answer option 2. So the reaction is spontaneous under all temperature. That's answer option 2. Because since delta S is equal to 0, this term will vanish. So you will get only minus delta H, because delta H is less than 0, minus delta H, so delta G is equal to minus, spontaneous. Anyway, we can discuss 3 and 4 also. So third one, delta H greater than 0 and delta S less than 0. Third one, delta H greater than 0 and delta S less than 0. Delta H greater than 0 and delta S less than 0. Delta H greater than 0 means it is positive. Delta S less than 0 means negative. So according to Gibbs equation, delta G is equal to delta H minus T delta S. Here delta H positive minus T into delta S is negative, right? So minus into minus plus. So delta H plus T delta S. Now if you add these two values, you will get always a positive value, because delta H is positive. T delta S is also positive. Positive plus positive, you will get a positive value. So this reaction is always non-spontaneous. So this is not the right answer. So 1 and 3 are not the right answer. Moving on to last one, fourth one. Delta H less than 0, delta S greater than 0. Negative, positive. So delta G is equal to delta H minus T delta S. Here delta H is negative, that is minus delta H minus T into delta S, positive. Minus H, minus delta H minus T delta S. Let the value of H be 2. So minus 2. Let the value of T delta S be 3. So minus 3, you will get minus 5. In a similar way, minus delta H minus T delta S, you will get delta G negative, spontaneous. So here also delta G value is negative. So delta G value negative and delta G value negative. So in these two reactions, delta G value is negative. So those two reactions are spontaneous. We have to mark only one equation, but here 2 and 4, both 2 and 4 are spontaneous reactions. So you can mark any one of those, 2 or 4. You can mark either 2 or 4. Both the reactions are spontaneous, because both the reaction gives delta G value negative. I think it's clear. Okay, moving on to next question, question number 5. Moving on to question number 5. Now question number 5. The heat of combustion of carbon dioxide is 393.5 kilojoules per mole. The heat of combustion of carbon dioxide is 393.5 kilojoules per mole. The heat released upon formation of 35.2 grams of carbon dioxide from carbon and oxygen is. So, what is heat of combustion? Heat of combustion means enthalpy of combustion. You know what is enthalpy of combustion? We have discussed enthalpy of combustion, right? Delta Hc. What is enthalpy of combustion? It is the enthalpy change occurring when 1 mole of a substance burned in excess of air or oxygen. You know that. We have discussed this in our topics. So, enthalpy of combustion means it is the enthalpy change occurring when 1 mole of a substance burned in excess of air or oxygen. So, enthalpy of combustion of carbon dioxide. Enthalpy of combustion of carbon dioxide is given. It is minus 393.5 kilojoules per mole. Enthalpy of combustion of carbon dioxide is given, right? It is minus 393.5 kilojoules per mole. Okay. The heat released upon formation of 35.2 grams of carbon dioxide. So, first we can write the equation. 1 mole of carbon react with oxygen to form carbon dioxide. This reaction is known as combustion reaction. This reaction is combustion reaction. What is combustion reaction? 1 mole of substance burned in excess of air or oxygen. 1 mole of substance burned in excess of air or oxygen to form product. So, enthalpy of combustion of carbon dioxide means 1 mole of carbon react with oxygen to produce carbon dioxide. And value is delta H. Okay. Now, what is the weight of 1 mole? Here 1 mole carbon dioxide is produced. 1 mole carbon dioxide, for producing 1 mole carbon dioxide, minus 393.5 kilojoules of energy is liberated. For producing, enthalpy of combustion of carbon dioxide is this much. That means carbon react with oxygen to form carbon dioxide. Here 1 mole of carbon dioxide is produced. So, to produce 1 mole of carbon dioxide, 393.5 kilojoules of energy is liberated. Okay. So, what is the mass of 1 mole carbon dioxide? Carbon 12 plus O2 32, you will get 44. So, 44 gram. Right. So, 44 gram of carbon dioxide. When 44 gram of carbon dioxide produced, minus 393.5 kilojoules per mole energy is released. Right. 1 mole carbon dioxide means 44 gram. So, 44 grams carbon dioxide, when 44 grams carbon dioxide produced, minus 393.5 kilojoules of energy is released. Then, to produce 1 gram of carbon dioxide, energy released is minus 393.5 divided by 44. This much of energy will be liberated. Okay. Now, if you read the question, they have given the heat energy liberated or released upon formation of 35.2 grams of carbon dioxide. So, to produce 1 gram of carbon dioxide, this much of energy is liberated. So, to produce a 35.2 grams carbon dioxide, energy liberated. 1 gram, this much of energy. So, 35.2 grams to produce this much of carbon dioxide, energy released is minus 393.5 divided by 44 into 35.2. Now, first multiply these two, then divide by 44. You will get an answer, and you will get nearly, answer will be equal to minus 314.8 kilojoules. Answer will be energy liberated as minus 314.8 kilojoules. Minus 314.2 kilojoules. Minus 314.8 kilojoules. Answer option. I think answer option 3. Minus 315. Yeah. Minus 315 kilojoules. Answer option 3. Answer option 3. I think it's clear. I'll explain once more. Here, enthalpy of combustion of carbon dioxide is given. Heat of combustion means enthalpy of combustion. Enthalpy of combustion. What is enthalpy of combustion? It is the enthalpy change occurring when 1 mole of substance is burned in air or oxygen. So here, 1 mole of carbon dioxide burned in air or oxygen to produce carbon dioxide. And enthalpy released is minus 393.5. So to produce 1 mole of carbon dioxide, energy released is minus 393.5. 1 mole of carbon dioxide contain 44 gram. So 44 gram of carbon dioxide produced and minus 393.5 kilojoules energy liberated. So 1 gram, to produce 1 gram of carbon dioxide, energy released is minus 393.5 divided by 44. Now here we have to calculate energy liberated upon formation of 35.2 grams of carbon dioxide. So to produce 1 gram of carbon dioxide, this much of energy is liberated. So to produce 35.2 gram carbon dioxide, minus 393.5 divided by 44 is the energy released when for 1 gram. So 35.2 gram multiply with 35.2 gram, you will get minus 314.8 kilojoules, which is equal to minus 315 kilojoules. I think it's clear. This is the important point. Enthalpy of combustion means it is the enthalpy change accompanying when 1 mole of a substance burnt. Here 1 mole of carbon burned to produce 1 mole of carbon dioxide, and from that we came to the answer option 3. I think it's clear. Moving on to question number 6. For the reaction X2O4 liquid to 2XO gas, delta U is equal to 2.1 kilocalories and delta S is equal to 20 calories Kelvin inverse at 300 Kelvin. What is delta G? So we have to calculate delta G. What is delta G? Delta G is equal to, equation to calculate delta G is equal to delta H minus T delta S. Here delta S is known, temperature is known here, but delta H, it is unknown function. So we have to calculate delta H. Here delta U is given. Equation is X2O4 liquid giving 2XO gas, right? Now by using delta U, you can calculate delta H. Relation between delta H and delta U is delta H is equal to delta U plus P delta V, or delta H is equal to delta U plus delta NGRT. Okay, here we can neglect this equation because P and delta V's are not given. Now by using this equation we can calculate delta H. What is delta Ng? Number of moles of product in gaseous state minus number of moles of reactants in gaseous state. Here product exists in gaseous state, number of moles 2, minus reactant is liquid, there are no gaseous reactants, so you can take gaseous reactant 0, number of moles of gaseous reactant 0, so delta Ng is equal to 2. So delta H is equal to delta U plus delta NGRT, right? So delta H is equal to, what is delta U? 2.1 kilocalories. Convert this into calories. You will get 2.1 into 10 raised to 3 calories plus delta Ng. Delta Ng is equal to 2. 2 into, now you have to remember one point, R value in joules is 8.314 joules Kelvin inverse mole inverse. This is the value of R in joules. But here energy is expressed in calories. R value in calories is 2 calories Kelvin inverse mole inverse. So value of R in calories is 2. It is 2. Value of R in joules is 8.314 joules Kelvin inverse mole inverse. But for value of R in calories is 2 calories. So because here everything is given in calories. So R value, you have to take R value in calorie. So R2 into temperature 300. That is 2100 plus 2 2s are 4, right? 4, or like you will get 300 to 600 to 1200, right? So 2100, you will get 3300. This is the value of delta H. So you got delta H is equal to 3300. Now we have to calculate delta G. Now we got delta H value. Now from that we have to calculate delta G. So delta G is equal to delta H minus T delta S. Here delta H is, we calculate the value of delta H is 3300 minus temperature 300 into delta S 20, right? So 3300 minus 6000, right? 3300 minus, you will get 6000. So 3300 minus 6000, you will get minus 2700 calories. Delta H is minus 2700 calories, or equal to minus 2.7 kilocalories. Answer is minus 2.7 kilocalories. Option B. Right answer, option B. So 3300, H is 3300 minus T, 300 into 200, 6000. So 3300 minus 6000 is minus 2700 calories, which is equal to minus 2.7 kilocalories. Answer option B. I think it's clear. Moving on to next question, question number 7. In which of the following reactions standard reaction entropy change, delta S, is positive, and standard Gibbs free energy change, delta G, decreases sharply with increase in temperature? So just calculate, just find where delta S value is. So here we have to find in which case entropy increases. So in first one, solid magnesium react with gaseous oxygen to form solid. We know that entropy is maximum in the case of gas compared to solid. Entropy is maximum for liquid. Compared to liquid, entropy is maximum for gas. Right? Entropy increases from solids to gas. Solids to gas, entropy increases. Here, solid reactant and gaseous oxygen react to form again solid. That means product, when they form product, entropy decreases. We have to find where entropy increases. Entropy increases means delta S value positive. Here, solid and gas changes to solid. So here entropy decreases. This is not the answer. Now, solid and gas convert to gas. This may be one of the answer. I don't know. We have to find. Solid and gas changes to gas. This may be the answer. Gas changes to gas. Now, if products are gas, then calculate delta N value. What is the value of delta Ng here? In first case, second case. In second case, delta Ng value is number of moles of products in gaseous state minus number of moles of reactants in gaseous state. Number of moles of product in gaseous state, half, minus number of moles of reactants in gaseous state, half. Half minus half, 0. Equation third, delta Ng is equal to number of moles of products in gaseous state, 1, minus number of moles of reactants in, this is gas, this one is solid, half. You will get half. Third one, delta Ng, number of moles of product, not third one, fourth one, number of moles of gaseous products, 1. Number of moles of gaseous reactant, 1. This one is gas and this one is also gas. 1 plus 1 by 2, that is 3 by 2, which is equal to minus 1 by 2. 0, 1 by 2, minus 1 by 2. In which case number of moles of gaseous molecule increases? In which case number of gaseous molecule increases? Here number of gaseous moles 0, half, delta. So here in this case number of gaseous molecule increases. Half gas changes to 1 gas. That means gaseous increases. Number of gaseous molecule increases. So option 3 is the right answer. I think it's clear. I'll explain once more. Entropy increases means delta S value positive. For if delta S value is positive, then entropy increases. In first equation, solid and gas changes to solid. Solid, liquid, gas. Compared to these three, gaseous state is having maximum entropy. So solid and gas is changing to again solid. Entropy decreases. Remaining three case, solid gas changes to gas, solid gas changes to gas, gas changes to gas. If products contain only gas, then it is better to calculate delta N. In this case, second case, delta N is 0. Entropy, like a number of moles in both the state, reactant and product, remain same. So there is not much change. Gas, here, third case, half moles increases. Compared to reactant, half moles gaseous product increases. That means, compared to reactant, number of gaseous product increases. Here half, here 1. So half gas molecule increases. Gas molecule increases. So entropy increases. Here 1.5, that is 1.5 gas changes to 1 gas. Here number of moles, gaseous moles decreases. Number of gaseous molecule decreases. So that entropy decreases. So answer is option 3. I think it's clear. Here half gas changes to 1 gas. That means gas molecule increases. As gas molecule increases, entropy increases. So answer is option 3. I think it's clear. Moving on to question number 8. The standard enthalpy of vaporization for water at 100 degrees 40.66 kilojoules per mole. The internal energy of vaporization of water at 100 degrees Celsius in kilojoules per mole is. So here enthalpy, standard enthalpy of vaporization is given. What is vaporization? What is vaporization reaction? Conversion of 1 mole of water to vapor. Water to vapor. 1 mole of water is converted to water vapor. Okay, this reaction is known as vaporization reaction, and enthalpy change accompanying this reaction is enthalpy of vaporization, delta H VAP, and it is given as enthalpy of vaporization of water. It is given as 40.66 kilojoules per mole. You can convert this into joules, that is 40.66 into 10 raised to 3 joules per mole. So conversion of water to water vapor is known as vaporization reaction, and conversion and the enthalpy change accompanying this reaction, liquid to water vapor. Liquid, water is liquid and water vapor is gas, so conversion of liquid water to vapor, water vapor, is known as vaporization reaction, and enthalpy change during this reaction is given 40.66 into 10 raised to 3 joules per Kelvin. Sorry, joules per mole. Now temperature is given there 100 degrees Celsius. Temperature 100 degrees Celsius, which is equal to 373 Kelvin. Right. Now we have to calculate the internal energy of vaporization. We have to calculate delta U. So delta H is given, temperature is given, delta U is given. What is the relationship between delta H, delta U and temperature? We have two equations relating delta H and delta U. First one is delta H is equal to delta U plus P delta V, and second one is delta H is equal to delta U plus delta NGRT. Now here pressure and volume is not given, so this is not the equation, but temperature is given. We know the temperature, so this is the relationship between delta H and delta U. Delta H is equal to delta U plus delta NGRT. So delta H is equal to delta U plus delta NGRT. Now we have to calculate delta U. So what is delta U? Delta H minus, I'm taking this del NGRT to this side, so delta H minus delta NGRT. Now what is delta NG? Here we know the value of delta H. Delta H is 40.66 into 10 raised to 3 joules minus R is 8.314, temperature 373. Now what is the value of delta Ng? What is delta Ng? Delta Ng means number of moles of products in gaseous state minus number of moles of reactants in gaseous state. This is the equation to calculate delta Ng. Delta Ng is equal to number of moles of products in gaseous state minus number of moles of reactants in gaseous state. In this equation, product is gas and there is 1 mole. So it is 1 minus reactant is liquid. There are no gas in the reactant side. Product side contain 1 gas. Product side contain gas molecule. Number of gaseous product 1 minus number of gaseous reactant. There are no gaseous reactants here. This is liquid. So it is 0. 1 minus 0, 1. So that is 1 into delta Ng is 1. What is delta Ng? Number of moles of product in gaseous state minus number of moles of reactants in gaseous state. Here this is product. This is gas, right? Product is gas. It contains 1 mole. 1 minus reactant. There are no gas molecule. So 0, 1. So it is equal to 14.66 into 10 raised to 3 minus, you have to multiply these two, 8.314 into 373. Now after multiplying you will get, after multiplying and subtracting, you will get, if you multiply these two and subtract from this one, you will get value nearly equal to 3756 something. 3756 something, this much of joules, and to convert this into kilojoules, you will get 37.567 kilojoules. 37.567 kilojoules. So first multiply these two, then subtract this from this one, you will get 567 joules, which is equal to 37.56 joule. 37.56 joule. Answer option 3. You will get answer as option 3. Option 3. Right answer is option 3. I think it's clear. Answer is option 3. Question number 8. Moving on to question number 9. Next question number 9. Moving on to next question number 9. So moving on to question number 9. The enthalpy of fusion of water is 1.435 kilocalories per mole. The molar entropy change for melting of ice at 0 degrees Celsius is. So they have given the enthalpy of fusion, delta H FUS is given. Delta H enthalpy of fusion is 1.435 kilocalories per mole. So convert this into calories, kilocalories to kilo. Sorry, convert this kilocalories to calories. So 1.435 into 10 raised to 3 calories per mole. Right. 1.435 10 raised to 3 calories per mole. Now we have to calculate the entropy change of melting of ice. So ice melt to form water. So enthalpy change. Enthalpy during this reaction is known as fusion reaction. So enthalpy change during this fusion reaction is enthalpy of fusion, and that is 1.435 into 10 raised to 3 calories per mole. Now during this fusion reaction there is change in entropy. Entropy means disorder. There is change in disorder. So let the disorder of this be S1, this be S2. So there is a change in disorder. Here let the enthalpy be H1 and enthalpy of water be H2. Since there is a change in enthalpy, likewise there is a change in entropy, that is delta S. So we have to calculate delta S. The molar entropy change for the melting of ice at 0 degrees. So we have to calculate entropy change S1 delta S, that is S2 minus S1. We have to calculate entropy change during this reaction. Enthalpy change is given when ice convert to water, that is fusion reaction. During fusion reaction there is a change in enthalpy, and that enthalpy change is given. We have to calculate entropy change. Now temperature is given, that is 0 degrees Celsius, which is equal to 273 Kelvin. Now we know that delta S is calculated using this equation. Delta S is equal to Q reversible by T. Now when we discussed about enthalpy, I have given one equation. I don't know whether you remember that equation. Delta H is equal to QP. Enthalpy change is equal to QP. I think you remember this equation. Delta H is equal to QP. We discussed nearly 6 equations for enthalpy. Delta H is equal to delta U plus P delta V. Delta H is equal to delta U plus delta NGRT. Delta H is equal to QP. Delta H is equal to CP delta T. Delta H is equal to enthalpy of product minus enthalpy of reactant. And delta H is equal to bond enthalpy of reactant minus bond enthalpy of product. We nearly discussed 6 equations. And one of the equations is delta H is equal to QP. Now, all the process in the nature take place at constant pressure. All the process in the universe, all the process in the universe take place at constant pressure. That means ice to water, melting of ice to water take place. It takes place by absorbing heat, and that heat is at constant pressure. The ice is absorbing heat to convert to water at constant pressure. So let the conversion be QP. Ice convert to water by absorbing heat energy, and all the process in the nature always occurs at constant pressure. So let the heat absorbed be QP. So we can write delta S is equal to Q reversible by T, or you can write QP by T. QP by T, sorry. Delta S is equal to Q reversible by T or QP, because heat is absorbed at constant pressure, so QP by T. Now we know that what is QP? Delta H. Here delta H is given, so instead of QP we can write delta H FUS, fusion by T. That is delta S is equal to delta H FUS by T. I think it's clear till here. I'll explain once more. Enthalpy change of melting of ice as given, and we have to calculate entropy change of this reaction, melting of ice. Now ice melts to water by absorbing heat energy. All the process in the universe occurs at constant pressure. That means ice is absorbing heat at constant pressure, so the absorbed heat be QP. Okay. Now we know an equation relating QP and delta H. What is QP and relation between QP and delta H? Delta H is equal to QP. This is one of the equation of delta H. So delta S, entropy change is calculated by Q reversible by T, or here heat is absorbed at constant pressure, so QP by T. Now what is QP? QP is delta H. So delta H FUS by T. So delta S is equal to delta H FUS by T. Enthalpy of fusion is 1.435 into 10 raised to 3, and temperature is 273 Kelvin. Now if you divide 1.435 into 10 raised to 3 divided by 273, you will get nearly a value 0.005. You will get 5 calories. You will get 5 calories. Kelvin inverse, mole inverse. You will get 5 calories, Kelvin inverse, mole inverse. 5 calories, Kelvin inverse, mole inverse. Answer is option 1, 5.260 calories. Okay, 5 is enough. If you divide this to divide with this, you will get nearly 5 point something. Okay, so I'm writing just 5.260. Let it be 5 kilocalories inverse, calories, Kelvin inverse, mole inverse. This is the answer for question number 9. Delta S value is 5. I think it's clear. Instead of QP, I am substituting delta H. Instead of Q reversible, I am substituting QP because heat is absorbed at constant pressure. Now instead of QP, I am substituting delta H FUS. It is already know the value of delta H, so substituting you will get 5.260. I am writing only 5. So 5 calories, Kelvin inverse, mole inverse. I think it's clear. Moving on to next question, question number 10. Okay, so I am writing just 5.260. Let it be 5 kilocalories inverse, calories, Kelvin inverse, mole inverse. This is the answer for question number 9. Delta S value is 5. I think it's clear. Instead of QP, I am substituting delta H. Instead of Q reversible, I am substituting QP because heat is absorbed at constant pressure. Now instead of QP, I am substituting delta H FUS. It is already know the value of delta H, so substituting you will get 5.260. I am writing only 5. So 5 calories, Kelvin inverse, mole inverse. I think it's clear. Moving on to next question, question number 10. Moving on to question number 10. Equal volume of two monoatomic gases A and B at the same temperature and pressure are mixed. The ratio of specific heats Cp by Cv of the mixture will be. So, two monoatomic gases A and B are mixed at same temperature. We have to find the ratio of Cp and Cv. Cp by Cv. We have to calculate the value of Cp by Cv. Now, before discussing the answer, I have to tell you some important things relating Cp, Cv and gamma. Now, gases are of three types. Monoatomic, diatomic, triatomic. Not three types, there are different types. Triatomic, tetraatomic, pentatomic, hexatomic. There are different types of gases. We are concentrating more on these three gases. Monoatomic gases, diatomic gases and triatomic gases. What are monoatomic gases? Monoatomic gases means gases that can exist alone. For example, helium always exists as He. It will not react with any other He. So it always exists as He, a single atom. Helium, argon always exists as Ar. Okay, neon always exists as Ne. They are monoatomic. They usually exist in a single. They will usually exist without combining with others. But oxygen is a diatomic gas. It exists as O2. Two oxygen combines. Okay, diatomic. Nitrogen N2. Chlorine Cl2. Two chlorine attached. Fluorine F2. Hydrogen H2. So these are diatomic gases. Right. Triatomic gases means gases which contain 3 atoms. Example, carbon dioxide. Now, these triatomic gases are again classified into 2 types: linear, non-linear. Carbon dioxide is a triatomic gas and it is linear. Whereas non-linear triatomic gases, example, ozone. Ozone is a bend-shaped triatomic. It's a bend. It's not linear. So you can classify gases into 3 categories: monoatomic, diatomic, triatomic. Not 3, there are different variety. We are giving more concentrations on these 3 type gases: monoatomic, diatomic, triatomic. Monoatomics, they exist without combining with others. Diatomic, they usually exist by combining with another atom, 2 atoms. Triatomic means 3 atoms. Now, triatomics are again classified into linear, non-linear. Linear means linear shaped triatomic. Non-linear means they will be bent or some other shape, not linear. Now, for monoatomic gases, CV value is always 3/2R. For monoatomic gases, CV value is always 3/2R. CP value is 5/2R. That is, we know that CP minus CV is equal to R. You know this equation. CP minus CV is equal to R. So if you know the value of CV, then what is value of CP? CP is equal to R plus CV, that is R plus 3/2. R plus 3/2R, you will get 5/2R. So if you know the value of CV, you can easily calculate CP. So for monoatomic, CV value is 3/2R and CP value is 5/2R. For diatomic, CV value is 5/2R and CP value is 7/2R. Now for linear triatomic, CV value is 7/2R, CP value is 9/2R. It is easy to remember: 3/2, 7/2. Sorry, 5/2. Now for diatomic, 5/2, 7/2 R. Now for triatomic linear, 7/2R, then add 2R. 3/2R plus 3/2R plus 1R, 5/2R. So you can remember these two. Now second one, diatomic start with 5/2R. 5/2R plus 1R, 7/2R. Triatomic linear start with 7/2R. 7/2R plus 1R, 9/2R. Now for non-linear, CV value is 3R and CP value is 4R. 3R, 4R. Now next is gamma. What is gamma? Ratio of CP by CV. CP and CV. Ratio of CP and CV. Gamma is equal to CP divided by CV. CP by CV. Now for monoatomic, CP value divided by CV value. That is 5/2R divided by 5/2R divided by 3/2R. 2 cancel, RR cancel, 5/3. 5/3 is 1.66. So gamma value, that is the ratio of CP and CV. Gamma is equal to CP by CV. For monoatomic, gamma value is 1.66. For diatomic, gamma value, CP by CV, 7/2R divided by 5/2R, you will get 1.4. For triatomic linear, gamma value is 1.28. 9/2R divided by 7/2R, you will get 1.28. And for triatomic non-linear, gamma value is 1.33. 4R by 3R. Okay. So this is the gamma value. Now we can read the question once more. Equal volume of 2 monoatomic gases. 2 monoatomic gases are mixed, A and B, at same temperature and pressure. The ratio of CP and CV. 2 monoatomic gases are mixed. Monoatomic, they won't combine. If you consider helium and argon, they won't react. They are monoatomic. They usually exist without combining with others. So when you mix 2 monoatomic gases, they will exist as such without combining. So what will be the value of gamma? Gamma value is 1.66 because they exist as monoatomic. When you mix 2 monoatomic gases, they are monoatomic. Monoatomic means they won't combine with others. So when you mix 2 monoatomic, they will stay like that. So what will be the value of gamma? If they combine, they will become diatomic. But monoatomic will not combine. They will exist as such. So gamma value is 1.66. Answer, it's equal to answer option 4, 1.67. Okay, you can take nearly 1.66. So answer option 4, 1.67. Sorry, 1.67. Yeah, answer option 4. I think it's clear. So you have to remember all these values, Cp, Cv and gamma values for all the three types of gases: monoatomic, diatomic and triatomic. I think it's clear. Moving on to next question, question number 11. Moving on to next question, question number 11. Moving on to question number 11. Which of the following is correct option for free expansion of an ideal gas under adiabatic condition? Which of the following is correct option for free expansion of an ideal gas under adiabatic condition? So here under adiabatic condition, so we know that adiabatic condition, adiabatic means Q value will be equal to 0. So under adiabatic condition, Q value will be equal to 0. Q value will be equal to 0. Now, which of the following is the correct expansion for free expansion? Free expansion. What does mean by free expansion? Free expansion. Expansion means expansion in vacuum. I think you remember we discussed this in our classes. So free expansion means work will be equal to 0. Irrespective of the nature of the work, whether it's irreversible work or reversible work, value will be equal to 0 if expansion is under vacuum or vacuum condition, or whether the process is free expansion. I'll explain once more. Whether irrespective of the nature of the work, whether it's irreversible or reversible, if reaction occurs under vacuum condition, then that expansion is known as free expansion. For free expansion, work will be equal to 0. Whether it's irreversible or reversible, work value will be equal to 0 for free expansion. Okay, free expansion means expansion in vacuum. So W value will be equal to 0. Now, so Q is equal to 0, W is equal to 0. Now, according to first law of thermodynamics, we know that delta U is equal to Q plus W. Here, Q is equal to 0, W is equal to 0. Obviously, what will be the value of U? It will be equal to 0. Delta U is equal to 0. So, answer is Q 0, W 0, delta U 0. Now, tell me, which is the right answer? Which is the right answer? Q is equal to 0, delta T, W. Q0, delta T. So, in all the answers, they have given delta T, not delta U. Q0, W0, delta, they have given delta T, not delta U. But we know that for isothermal process, already we discussed this one. For isothermal process, two terms will be equal to 0. Delta T and delta U. These two functions will be equal to 0. We have discussed this one. So that means when delta U is equal to 0, that means the reaction is isothermal. For isothermal, delta T will be also, it will be equal to 0. So Q0, W0, instead of delta U, you can write delta T is equal to 0. Because for isothermal process, delta U will be equal to 0. Along with delta U, delta T will be equal to 0. So instead of delta U, you can write delta T also. So this is the right answer. Q is equal to 0, W is equal to 0, delta T is equal to 0. Answer option 4. Answer option 4. Option 4 is the right answer. Q is equal to 0, W is equal to 0 and delta T is equal to 0. I think it's clear. You have to remember one point. For isothermal process, these two conditions, that is change in temperature and change in internal energy, these two conditions will be equal to, or these two functions will be equal to 0. I think it's clear. Moving on to next question, question number 12. If the enthalpy change for the transition of liquid water to steam is 30 kilojoules per mole at 27 degrees Celsius, the entropy change for the process is. So here enthalpy change is given. Enthalpy change of transition of liquid to water. So liquid, that is water, liquid water, okay, water to vapor. So here enthalpy of transition of water to water vapor is given, water vapor. Enthalpy delta H is equal to, it is given as 30 kilojoules per mole. So 30 kilojoules per mole. So enthalpy of vaporization, we know that conversion of water to water vapor is known as vaporization reaction. Vaporization reaction, and enthalpy of vaporization is 30 kilojoules per mole, 30 kilojoules per mole, right? So convert this into joules, that is 30 into 10 raised to 3 joules per mole. Now temperature is given, it's given as 27 degrees Celsius, which is equal to 300 Kelvin. 27 degrees Celsius means 300 Kelvin. Now the entropy change for the process, so we have to calculate entropy change, delta S, entropy of vaporization. We have to calculate entropy of vaporization. Already we discussed this in question number 9 or 8, I forgot the number. Here water convert to water vapor by absorbing heat. So entropy is calculated, entropy of vaporization is calculated by Q reversible by T, right? Now here heat is absorbed by water to convert to water vapor. Water will absorb heat energy to convert to water vapor. All the process in the nature or universe take place at constant pressure. So let this be QP. So water will absorb QP, heat at constant pressure. Heat amount, heat energy at constant pressure to convert to water vapor. So you can write this equation as delta S is equal to QP by T. Now what is QP? QP means delta H. So here we know the value of delta H to convert water to water vapor. So delta S VAP, vaporization, is equal to, instead of QP you can write delta H vaporization by T. Delta H vaporization is 30 into 10 raised to 3. That is 30,000 divided by temperature 300 Kelvin. 300. So you'll get 100 joules, Kelvin inverse, mole inverse. This is the entropy of vaporization of conversion of water to water vapor. 100 joules, Kelvin inverse, mole inverse. Answer option 100 joules, Kelvin inverse, mole inverse. Answer option 1. Answer option 1. I think it's clear. So here enthalpy of vaporization is given. We have to calculate entropy of vaporization, but we know that entropy is calculated by Q reversible by T. Here heat is absorbed at constant pressure. So QP by T. What is QP? Delta H. So substitute the value of enthalpy of vaporization. You will get that. Already we have done this question. I think question number 9 or 8. Conversion of ice to water. Entropy change for the conversion of ice to water. I think it's clear. Moving on to next question, question number 13. Enthalpy change for the reaction of 4H gas giving 2H2O gas is minus 869.6 kilojoules. The dissociation energy of HH bond is. Dissociation energy means bond dissociation energy or bond enthalpy. Okay. So here reaction is given, 4H gas convert to 2H2 gas. And enthalpy of this reaction is, enthalpy of reaction is minus 869.6 kilojoules, right? Now we have to calculate bond enthalpy. You have to calculate bond enthalpy. Now I think you remember one equation. Enthalpy of reaction can be calculated from bond enthalpy or bond dissociation enthalpy. Bond enthalpies and bond dissociation enthalpies both are same. So enthalpy of reaction can be calculated from bond enthalpies by using this equation. Bond enthalpy of reactant minus bond enthalpy of product. Bond enthalpy of reactant. Bond enthalpy of reactant minus bond enthalpy of product. This is the equation to calculate enthalpy change from bond enthalpies. Enthalpy of reaction. I think you remember last and sixth equation. To calculate enthalpy change. Delta HR is equal to bond enthalpy of reactant minus bond enthalpy of product. Now, here hydrogen exists as H. there are no bonds between 4 H's. There are no bonds. Here hydrogen exists as a monoatomic. There are no bonds here. So here bond enthalpy of reactant, this is 0. Here this is the reactant. So bond enthalpy of this one is 0 because there are no bonds between 4 hydrogen atoms. They exist as atoms. 1, 2, 3, 4. 4 hydrogen. Now here HH bond. H2 means it consists of HH bond. How many HH bond? 2 bond enthalpy of HH. Right. Product. This one is product and this one is reactant. So 2. How many H2 means consists of 1 HH bond. 2 hydrogen H2, that is 2 into bond enthalpy of HH bond. Right. So enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product. Here this is the product and this one is reactant. So delta HR is given minus 869.6 kilojoules, minus 869.6 kilojoules, and bond enthalpy of reactant 0 because these are the reactant. This is reactant and this one is product. Here there are no bonds between hydrogen atoms. 0 minus bond enthalpy of product. We have to calculate bond enthalpy of product, that is bond enthalpy of HH. How many? 2 bond enthalpy of HH, right? So bond enthalpy of HH bond is minus 869.6 divided by minus 2. I am taking this minus 2 here. So bond enthalpy of HH bond is minus 869.6 divided by minus 2, which is equal to, when you divide minus 869.6 divided by minus 2, you will get 434.8. You will get 434.8 kilojoules. 434.8 kilojoules. You will get 434.8 kilojoules. Answer option 4. 434.8 kilojoules. So you can see answer is option 4. So in question they asked the bond dissociation energy. This is bond dissociation energy. Bond dissociation energy is also known as bond enthalpy. Bond dissociation energy of HH bond. The bond dissociation energy of HH bond is 434.8. I think it's clear. I'll explain once more. Enthalpy of reaction can be calculated from bond enthalpy of reactants and product. Equation is enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product. Now this is the equation. Here bond enthalpy of reactant is 0 because there are no bonds between 4 hydrogen atoms. They exist as monoatomic. 4H. 0. Now how many HH are there? 2 HH. 1 H2 contain 1 bond. So 2 H2 means 2 into energy required to break down 1 HH bond is bond enthalpy of HH bond. Energy required to break down 1 HH bond is bond enthalpy of HH. Bond enthalpy of HH bond. So there are 2 H2. So 2 bond enthalpy of H2. Now according to this equation, enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product. Reactant is 0. Enthalpy of reaction minus 869.6 is equal to 0 minus 2 bond enthalpy of HH. So bond enthalpy of HH. This is the one they asked in the question. Calculate bond dissociation enthalpy of HH. That is bond enthalpy of HH is equal to minus 869.6 divided by minus 2. You will get 434.8. I think it's clear. Moving on to next question. Question number 14. Moving on to next question, question number 14. Consider the following process. Okay, consider the following process. One side contain reactions and second side contain enthalpy change in kilojoules per mole. So we have to calculate delta H for B plus D giving E plus 2C. So here 3 reactions are given. Half A giving B, 3B giving 2 plus C, E plus A giving 2D. And the delta H values in kilojoules are given. Delta H is 150 and for this reaction minus 125, for this reaction 350. Now we have to calculate enthalpy change for this reaction B plus D giving E plus 2C. We have to calculate enthalpy change of this reaction B plus D giving E plus 2C. Okay. Now if they have given some other equations and they asked to calculate enthalpy change for a particular equation, if they have given some equations and they asked to calculate enthalpy for some other equation, you can find or you can make this equation from these equations. You can make this equation from these equations. Let this equation be 1. Let this equation be 1, 2 and 3. Now they asked to calculate enthalpy of this equation and they have given some equation. By using these 3 equations you can make this equation. I'll explain. Consider this as equation 1, this as equation 2 and this as equation 3. Now, okay, here we are not, there are no A terms here. There are no A terms, A. Alphabetic A is not there. But in these equation A is there. So, the main idea is you have to cancel out A. Then only, first you have to cancel out A. First and third equation contain A. You have to cancel out A. Then only, if A cancel each other, then this equation. Okay. We are forming this equation from these 3. If you cancel out A terms, then you can make this equation. Okay. Now, here, third equation contain E plus A. First equation contain half A. So, I am multiplying first equation into 2. 1 into 2. So, you will get A giving 2B and delta H value will become, I am multiplying with 2, it will become 300. Okay. Second equation is, I am going to write that equation as such, that is 3B giving 2C plus D minus 125. Third equation, E plus A giving 2D. So I am going to multiply only first equation with 2, first equation into 2. You will get A plus giving 2B. Why I am multiplying with 2? Because we have to find enthalpy for this equation, and in this equation there are no A terms. There are no terms with A. That means we are going to make this equation from these equations, so we can cancel out A so that we can make this equation. That is the idea. So here third equation contain 1A and first equation contain half A. So we are going to make these 2A same. So I am multiplying first equation with 2. So I will get A is equal to 2B. 2B 350. And E plus A is equal to 2D 350. Now I am going to subtract. Okay. Adding these 2 equations, I am going to subtract this equation. Adding these 2 and going to subtract this equation. So adding these 2 and going to subtract this equation. That is 1, okay, into 2. First equation into 2 plus second equation minus third equation. So I am going to minus third equation. So minus E minus A minus 2D minus 350. So minus A and plus A, they will cancel each other. Right. Remaining terms are minus E plus 3B this side. That side contain 2B 2C, and this is minus 2D and this is D. So 1D and 2 will cancel out. So minus D. Right. Now rearranging, I am taking 2B to this side and D to this side. I am taking 2B to this side and D to this side. So you will get 3B. I am taking 2B to this side minus 2B. I am taking D to this side plus D. Minus D will become plus D. 2B will become minus 2B, giving, I am taking E to that side. So 2C plus E. What is 3B minus 2B? B. So B plus D giving 2C plus E. Right. B plus D giving E plus 2C. Right. So we made this equation from these 3 equations. Right. Now what is the enthalpy change? Here enthalpy of first equation is 300. Second equation is minus 125. And we subtract third equation. Enthalpy of third equation is 350. Since there is one minus, we are subtracting third equation. This will become minus 350. It will become minus 350. So 300 minus 125 minus 350. Now when you calculate these 3, you will get minus 175. You will get minus 175. You will get minus 175. I think it's clear. This is how we find delta H for this equation. From these three equations, we calculated delta H for this equation. Delta H is equal to 1 into 2, so 150 into 2, 300, plus 2, minus 125, minus 3. 3 is 350, minus 3 means minus 350. Adding these 3, you will get minus 175. I think it's clear. Moving on to next question. So answer option 4. Answer is option 4, minus 175 kilojoules per mole. Minus 175 kilojoules per mole. I think it's clear. Moving on to next question, question number 15. Moving on to next question, question number 15. Moving on to next question, question number 15. The standard entropy of X2, Y2, XY3 are 60, 40 and 50 joules Kelvin inverse, mole inverse respectively. For the reaction half X2 plus 3 by 2 Y2 giving XY3, delta H is minus 30 kilojoules. To be at equilibrium, the temperature should be. So here, entropy of X2, Y2 and XY are given. Entropy of X2 60 joules Kelvin inverse mole inverse, Y2 40 joules Kelvin inverse mole inverse, and XY is 50 XY3. Sorry, XY3 it is 50 joules Kelvin inverse mole inverse. Now they have given a reaction half X2 plus 3 by 2 Y2 giving XY3, and delta H value is given. Delta H is equal to minus 30 kilojoules, which is equal to minus 30 into 10 raised to 3 joules. Okay. Now we have to calculate temperature when the reaction is at equilibrium. Temperature when the reaction is at equilibrium. Okay. So please listen carefully. Equation is half X2 plus 3 by 2 Y2 giving XY3. And delta H is given. Sorry. Delta H value is minus 30 kilojoules, which is equal to minus 30 into 10 raised to 3 joules. Now first we can write the entropy. What is the entropy of X2? 60. But here there is only half X2. So entropy of X2 is half into 60, which is equal to 30. Plus entropy of Y2 is 40. But there is only 3 by 2 Y2. So 3 by 2 into 40, 20. Giving, okay, 3 into 20. Giving XY3, 1 XY3 and 50. So it is 30 plus 20 into 3, 60 giving 50. Okay, I think it's clear till here. Now, what is delta S? Entropy of products minus entropy of reactant. This is the product and its entropy is 50. So 50 minus entropy of these two are reactant and their entropies are 30 and 40. Minus 30 plus 60. Not 30 and 40, 30 and 60. Sorry. So 30 plus 60. That is 50 minus 90, which is equal to minus 40. So entropy delta S is minus 40. I think it's clear. Delta S is minus 40. Okay. So I think we've calculated delta S. Now we have to calculate temperature when the reaction is at equilibrium. Okay. We know the relation between delta H, delta S and temperature. What is that? Delta G is equal to delta H minus T delta S. This is the relationship between delta H, delta S and T. Gives equation. Right. Now at equilibrium, they have given that at equilibrium what is the temperature? At equilibrium, delta G is equal to 0. So 0 is equal to delta H minus T delta S. Right. So I am taking T delta H to this side. So T delta S is equal to delta H. So temperature is equal to delta H by delta S. What is delta H? Minus 30 into 10 raised to 3. What is delta S? Minus 40. Right. So minus cancel each other. 0, 0. 3 by 4 into 10 raised to 3. 3 by 4. First calculate 3 by 4 into 10 raised to 3. You will get nearly 750 Kelvin. Answer is 750 Kelvin. 3 by 4 into 10 raised to 3. You will get 750 Kelvin. So answer is option 1. Answer is option 1, 750 Kelvin. I think it's clear. So they have given entropies of reactants and product. Okay. X2, Y2 is XY3. So first substitute those entropy value and calculate entropy of reactants and product. Then delta S. Entropy of products minus reactant, you will get minus 40. Now enthalpy, delta H is given for this reaction. Now at equilibrium, we have to find the temperature. Relation between delta H and temperature is Gibbs equation. Delta G is equal to delta H minus T delta S. At equilibrium, delta G will be equal to 0. 0 is equal to T delta S. From that, we calculated temperature. It is equal to 750 Kelvin. I think it's clear.